Okay, so we're back again, and starting with number 11 on the June 2015 Common Core exam for geometry. Let's see. So here we go. We're going to try to get some key information from this problem. Um, EB parallel to DC. So take a second and just mark the diagram. What you should see now is triangle AEB is now similar to triangle ADC. Now, with that information, we should get that sides are proportional. Let's put in this keyword, corresponding sides are proportional. So, we're looking for corresponding sides right now. Let's see. We are looking for the length of AC. So let's call that X. Now, that's the whole side of the bigger triangle. So let's get its corresponding side right there. Now, to set up the proportion, you could go 9 is to 14. Just be consistent. So we've got corresponding sides. 9.2 is to x. Cross multiply to solve. 9x equals whatever 14 times 9.2 is. Go to your calculator, 128.8. And we'll divide by 9. Oh, it is a decimal. It's about 14.3. One repeating. Nearest tenth, we got that choice. Okay, let's see. Scalene triangle. Okay, which is always true. Now, the purpose of scalene is so that we know that these two sides are not congruent. So cos of A will not be the same as cos B, and likewise there. So that was the point of saying it was scalene. All right, so this is a pretty typical problem. Basically, if angles in a right triangle are complementary, their measures add to 90 degrees. If that's the case, which is true for A and B, what we'll have then is their cofunction values will be equal. So basically you're looking at something like this. Cos of 40 degrees would be the same as sine of 50. So that type of idea. All right. Now this one's a little trick. They're taking sine of C. That's wrong. That's the one you want right there, because it's essentially this concept. Angles A and B, their measures, we're going to add to 90. So that's what we have there. All right. Okay. So we want to prove something's a parallelogram. So a quick sketch one. All right. So if the diagonals AC and BD bisect each other, that would be enough to make it a parallelogram. But we want, which is not sufficient. All right, let's mark this up here. AB congruent to CD and BC congruent to AD. That is enough. That will be enough to force it. Okay, let's go through this one. AB congruent to CD and AB parallel to CD. That again is enough. One pair of corresponding sides, parallel and congruent, is enough. Let's just see why the other one's not going to work. Here's the markings. Okay, AB congruent to CD, AD parallel to CD. I'm sorry, Oops, I marked the wrong one. No, that's right. That's correct. So that's the markings. Why? Now that could be a parallelogram. What we have to consider is there another figure that wouldn't be a parallelogram that could have these properties? So let's check this out. I'm thinking about an isosceles trapezoid. Okay, if this is A, B, C, D this way, those are the same, right? And then BC parallel to AD, we could have us an isosceles trapezoid. That does not have to be a parallelogram, so that's why 4 is our choice. All right. Okay, so what we got to do on 14 is we're going to have to get the equation of a circle. Get all set up here. All right. We're going to have to take this equation, and we're going to have to, we could do it one of two ways. We could work at completing the square, or we could take the choices since it's a part 1. There is a way to do that. Take your choices and write the equation and see which one's the same as this. But I'll do it with the completing the square, showing you the algebra with that. So first I'll rewrite it. We don't need anything with x to complete the square, but we will need something for y. So we'll put a space in there, and whatever we add to the left, we'll add to the right. All right, so skip ahead a little bit. These 3 will turn into y plus 3 quantity squared. So what needs to go in this space for us to do that? It would be 9. 3 squared is 9. So that'd be the missing term. All right, so 7 plus 9. Sorry. Is 16. So now from here, we'll get the center and radius. Center, it's going to be 0, negative 3. Radius is the square root of 16. So that's 4. Let's see, we're looking at choice 2. All right, 15. If AB is 9 and BC is 15, DE is 6, EF is 10, B is congruent to E. All right, which statement is true? It looks like right now we could test this out. Is 9 over 6, is it equal to, make sure we're corresponding here, 15 over 10. We'll cross multiply, still a question mark. That is 90, that is 90. So what this just gave us was that the corresponding sides are proportional. What we have is basically a side angle side similarity setup. So these 2 triangles are similar. Let's go with ABC. Now, got to make sure E is in the middle, corresponds to B. All right, the shorter side is A to B. So D to E. We got to go D, E, F. All right, those are similar figures. And let's see. Is CAB congruent to DEF? No. Because this is tricky for some students. DEF again is this angle. Okay. And let's see. CAB is this angle. So right away, we can't be certain that those are the same. I'm going to probably lean, oh, that's false. I'm saying which one's true. That one's false. Okay. This one is the true one. All right, we just proved that by side angle side. Triangle similarity postulate. So that's the one that we're looking for. You could check the other ones, but they're not going to work out. So, all right, moving on to 16. Let's see. All right, so ABC is dilated by a scale factor of 3. So that means let's see. All right. So this is always tricky. Let's put in some numbers there. So let's assume we just make this up that AC is 10. Its corresponding side A prime C prime would be 30. Now these can be tricky right here. This one here. It looks like since A prime B prime is 3 times as big. All right. It's tricky right here because this looks right at first, but what people don't get is that that's already a bigger number. If you triple a bigger number, you can't make them equal. Okay, so this is going the wrong way. Now, is the image 3 times as big as the pre-image? That's what you want, okay, because your pre-image is smaller, multiply it by 3 to make them equal. That's the one we want. Angles, corresponding angles are congruent, so we don't want to triple their measures. Okay, that's not going to work. All right, so we're taking a look at this one. Which statement will allow Steve to prove these two parallel? Well, let's go highlight those quick. A, B, C, D is that. E, F, G is that. We want to prove that those are parallel. So we're probably thinking either corresponding or alternate interior angles here. Let's take a look. CFG would be there, and FCB. That is a perfect pair of alternate interior angles right there. If those are the same, okay, I tell my students look for the Z or backwards Z or N. That's it right there. Now we can check the other ones, ABF, BFC. No, that's not going to work. That's this spot and this spot here. Not going to work. So go through and check the other ones. I'm sure they're not going to be alternate interior angles that we need. So next, let's see. Scale factor is what we're looking for. All right, so here's what we could do here. When we dilate, if this is the center of dilation, okay, D and B are corresponding, okay? So the scale factor is going to be less than 1 because this is the pre-image, and this is the image according to what I read up here. CD is the image, okay? So the image is smaller and closer to the center of dilation, and that is a scale factor of less than 1. So what I like to do for my formula is I always like to say pre-image times scale factor equals image, and I always use that. Okay. Some people like to have a different formula for everything. I like to use one formula and manipulate that. So we don't know scale factor. Let's give ourselves a pre-image, maybe possibly AB. Okay. And its corresponding image is CD, the segment. Divide both sides by AB. And one possibility for K is CD over AB. Let's see if that's a choice. CD over AB. Great. Not one of our choices. All right, so let's look at this now. EC to EA is going to do that. All right, let's follow through. Here's why. The distance from EA would be our pre-image, following our formula up here. K is our scale factor, and its image would be EC. Okay, so we divide both sides by EA. And one possibility would be EC over EA. All right, so that's going to work for us. The rest are going to probably not be corresponding or possibly upside down. So, all right. Got to read this one. A gallon of paint will cover approximately 450 square feet, and we want to paint a cube, all the surfaces of a cube, right? 12 feet on each edge. So basically what we've got to look at is this is not a volume, but a surface area problem. Now, with a cube, that helps a little bit. Right? With a cube, there are 6 equal faces. Okay, so they'd all be squares as well. So all we're going to do is find the area of one square, multiply by 6, and that's how much, that's how many square feet we'll have to cover. So, so the area of one side, it is going to be 12 by 12, 144. Okay, and now we need 6 of those, so the total surface area. That's going to be 6 of those 144s. So, just go to your calculator quick, and we get 864. All right, if 1 gallon of paint covers 450 square feet, how many would we have to buy to finish it? The least number, of course, you're not going to buy a fraction of a can of paint from the store, so one can would get us 450. 2 would get us 900. That'll cover our 864, so 2 gallons of paint is all we need. All right, let's create some space. This is gonna number 20, a circles question. All right, so we have AC and CD. They're telling us AC is perpendicular, so that tells us as well, all right, that CD is a tangent. So that's an indirect way of telling us CD is tangent. Any radius and tangent will make a right angle, or diameter and tangent. Okay, so which statement is not always true? All right, let's go through this. Is ACB the same as BCD? Not necessarily, because if these bisect, or if BC bisects this, then yes, but it doesn't. They didn't say that up here, so we can't say that. All right, angle ABC, that's a right angle because it opens up to a diameter. And ACD is a right angle because they're perpendicular. That's the one. Oh, whoops. Sorry, it says which one's not always true. Missed that. Let me back up. Okay, so let's go back through this. This one is always true. Let's see, BAC, congruent to DCB. All right, so this is the intercepted arc for this problem. Let me get rid of some other stuff here. Okay, I'm looking at choice 3 right now. All right, BAC is this angle right here. It's an inscribed angle that opens up to this arc BC. So it's half. Let's just assume for a second, just to start working with some numbers, let's say for a second that that's 70. This would be 35. And DCB, okay, that's this one. A tangent and a chord will form an angle that's half of its intercepted arc. So that's also 35. That one is true. And I'm pretty confident the other one's going to be true as well. Let's just check. CBA is a 90. AEC is a 90 because they're angles that open up to a semicircle, inscribed angles. So they're going to be 90, half of 180. This is the one that's not always true. Now, little lesson, be really careful about that. You know, went right ahead and found one that was true and then looked back and realized they want which one's not always true. Okay, let's slide down to 21, almost through the part ones. Let's see. The trick on this one, it looks like, is that they shifted this around. Okay, so they took this figure here, instead of lining it up nicely, okay, so that we could easily match the corresponding parts. Uh, you know, we flip this around so that it's not as easy to get corresponding sides, but we'll manage. All right, so let's take a look here. AC is 12, DC is 7, D is 5, and the perimeter, okay, so the perimeter of ABC is 30, and they want the perimeter of this. Okay, now what we would look at is what is a pair of corresponding sides? Well, this is in fact still a pair of corresponding sides. Almost looks like they line reflected then dilated or something like that. Um, so assuming they did that, this is still a pair of corresponding sides. All right, so I can take this ratio 12 to 7, and it should be proportional even to the perimeters. Okay, sides and perimeters will have the same ratio. So if I have 12 to 7 is the ratio of a pair of corresponding sides, let's take a look now at the ratio of the perimeters. The perimeter is 30, and we want the other one, call it P, and we'll be able to solve. So 12P equals 210. And real quick, we'll take a look at that in the calculator. .210 divided by 12. I'm coming up with 17.5. And so choice 4. Okay. Pretty typical problem here. You'll see we can pretty much bet that this is going to be on there. When we dilate a line, we know we're at least going to get a parallel line. Now, if the center of dilation happens to be on the line, we will get the same line. Okay, so that's just the way that this problem works. It's something you have to memorize. So what I would do for a parallel line is I would want slopes to be equal. So I'll start with that. Now, in this format, we're not all used to it being this way. Okay, one option is to look and see, we've got x's over here. If I took the equation the way it is, and this seems odd, but if I added this over, I would get 2x plus 3y equals 8. Now, that's not y equals mx plus b like we're used to. Okay, but I can see right now that I'm down to the only possibility right now is that one. I know right away because I took this equation, made it look like that format, and the numbers where they are here are going to determine the slopes. Now, if you didn't like that explanation, that's fine. We'll go through the process that we taught in class. So let's go back to this original. 3y equals negative 2x plus 8. What we taught in class is that we would get it in y equals mx plus b form. All right, so our slope for this line is negative 2/3. We need a parallel line. So we know if we want a parallel line, we're going to need the slope to be equal. So we would have to go through all these choices and figure out which one of those choices has a slope of negative 2/3. So I'll just take choice 1 because I know it's the right one. 2x plus 3y equals 5. I'll subtract 2x. 3y equals negative 2x plus 5. And divide by 3. Look at that. It has the same slope. Right? The number in front of x is your slope. So that one is going to be the correct choice. They didn't give us anything else to work with, such as a scale factor, so we would never be able to find the appropriate y-intercept. They didn't give us the center of dilation either, so that was the only thing they were looking at. Was you knew that to dilate a line, the slopes are going to be equal. Okay. All right, this is an interesting way to demonstrate really area. Um, area, circumference, this is a neat way to look at it. So a circle with a radius of 5 was divided into 24 congruent sectors. So basically they're trying to show you the different, the setup here. So what we're doing is we're taking this, slicing it up. This is 24 slices. Not really sure what's going on here, but they're rearranging them, some up, some down, and now they're putting them together. This is the way we're going to demonstrate to you area of a circle. Okay, take all the sectors, arrange them so that it's almost like a rectangle. Now, if you knew anything about calculus, okay, the more slices, the closer this is going to approach to a rectangle. Right now, it looks a little bit like a parallelogram. You can almost see it. Okay. Now, the sides are approaching, and as we get them smaller and smaller and smaller, the slices, if you look, are basically the radius of the circle. Okay. And what happened was they arranged every other one back and forth. Okay. So it's essentially, all right, it's essentially an area problem. This was an area demonstration. Um, how long is this? Well, basically it's half the circumference, right? Because you've got all these little distances, okay, arranged this way, but it's only half of them. Half are pointing up, the other half are pointing down. So you got half the circumference to make up this distance right here. Well, the full circumference is 2 pi r, so half the circumference would be pi r. Now the radius in this case is 5, so what we're looking at is pi times 5. Now, 5 pi to the nearest integer, we're going to have to type it in the calculator. Probably around 15, somewhere in that range. So 5 times pi. There it is. 15.708. So we'd have to round up to 16, and that's how you do 23. All right, last one on the part ones. Okay, we need sufficient evidence to prove the triangles are congruent. All right, this is basically going to give us 2 pairs of sides, not going to be enough. 3 pairs of corresponding angles, not going to be enough. All right, this is what they want, right? There's a sequence of rigid motions that maps. There's a pair of sides, there's a pair of sides. Really, that's going to be side, side, side. That's pretty good. Okay, here's the trick on this one. Point A to point D is not enough. If that said angle A to angle D, we'd be all set. This would be correct too, but it's not. So that's the trick there, is it's just points matching. You need angles matching to get something like angle side angle or angle angle side. It's got to be choice 3, and that rounds out the part 1s for the June 2015 Common Core Geometry exam. Thanks for tuning in, and next one will be the open response.